Hello student, I am Dr.A.K Sinha, Professor of Chemistry. Today I am going to discuss Group 2 elements. Group 2 elements, also called alkaline earth metals. Last class I have finished completely Group 1 elements, all properties and compounds of sodium, important compounds of sodium I have finished. Now I am going to start Group 2 elements, also called alkaline earth metals. The Group 2 elements comprise beryllium, magnesium, calcium, strontium, barium and radium. They follow alkali metals in the periodic table. These are known as alkaline earth metals, except beryllium. The first element, beryllium, differs from the rest of the elements. Or members of the group, and show diagonal relationship to aluminum. Means beryllium is different from other members of the group, and it has a diagonal relationship to aluminum. The atomic and physical properties of the alkaline earth metals now I am telling you. Okay. But before going to this properties, physical properties, the atomic and physical properties of the alkaline earth metals, I want to tell about the electronic configuration. Then I will come to the atomic and physical properties. Electronic configuration. These elements have 2 electrons in the s orbital of the valence shell, means outermost orbit. Their general electronic configuration may be represented as first noble gas configuration, and after that ns square, small n, ns square. Like alkali metals, the compounds of these elements are also predominantly ionic. Group 2 metals are also ionic except beryllium. Now electronic configuration of beryllium, Be. Beryllium has a symbol Be. Magnesium has symbol Mg. Calcium Ca. Strontium Sr. Barium Ba. Radium Ra. Okay. Then now electronic configuration of beryllium, Be. Capital B, small e. 1s square, 2s square. Its atomic number is 4. Beryllium has atomic number 4. That's why its electronic configuration is 1s square, 2s square. Magnesium has electronic configuration 12, and its magnesium has atomic number 12, and its electronic configuration 1s square, 2s square, 2p6, 3s square. Okay, means in the last orbit 2 electrons are there, 2s square. In beryllium you have seen 1s square. In beryllium 2s square, and in magnesium 3s square. Like that way, calcium has atomic number 20, and its electronic configuration is 1s square, 2s square, 2p6, 3s square, 3p6, 4s square. Means beryllium was having and the end 2s square, magnesium and the end 3s square, calcium in the end 4s square. Like that way, strontium has 38 atomic number, and it has in the last it will have 5s square, calcium 4s square, and strontium Sr that is a 5 square, and its atomic number already told you 38. Now barium has atomic number 56, Ba, capital B, small a, Ba, and you can say last electron is, that is a 6s square. 6s square means before 6s square, Xenon, it have Xenon electronic configuration. Okay, because it is difficult to write electronic configuration. You can write, but telling it is long. That's why it is written as a noble gas configuration. Then barium 56, its atomic number is 56. Then it is written like first Xenon configuration, noble gas configuration you have to write, and in the end 6s square. And radium 88 radioactive element. Then this symbol is Ra, capital R, small a, Ra, and its electronic configuration is in the end 7s square, and before 7s radon configuration, Rn. Okay, this I have told you about the these things, electronic configuration. Actually, electronic configuration plays big role in telling about the physical properties as well as chemical properties. Now, atomic and ionic radii. The atomic and ionic radii means radius of the alkaline earth metals are smaller than those of corresponding alkali metals in the same periods. Here you should understand, because generally a student will think reverse way. Here you should understand the atomic radius and ionic radius of the alkaline earth metals are smaller than alkali. Okay, smaller than alkali metals in that period. Okay, smaller than those of the corresponding alkali metals in the same periods. Why? This is due to the increased nuclear charges in these elements. Nuclear charge will increase. When atomic number will increase, then nuclear charge will increase, but new orbital will be not opened. Not opened. Only in the outermost electron will go, but charge will increase. Nuclear charge means proton will go on the nucleus, then charge will increase, but this last orbit will be fixed. Okay, electron will go only in the last orbit. New orbit will be not opened in the same period. Okay, that's why size will be smaller. Okay, then due to the increased nuclear charge in the elements, size become smaller. Within the group, now I am talking about the group. Within the group, the atomic and ionic radii increases with increase in atomic number. If atomic number will increase in a group, then atomic radii and ionic radii both will increase. Okay. Now I am coming to this physical properties. Okay. Then here I am talking about now atomic and physical property of the alkaline earth metals. These data are very, very important. Then I will tell about all, you can say, elements. Okay. Then first atomic number you should know, already I told you, atomic number of beryllium is 4. Be. Symbol is Be. Atomic number 4. Magnesium Mg, its atomic number is 12. Calcium, its Ca, its atomic number is 20. Strontium Sr, its atomic number is 38. Barium, its Ba, its atomic number is 56. Radium Ra, its atomic number is 88. Okay. Now second important property, that is the atomic mass. Atomic mass gram per mole, in terms of gram per mole. Then beryllium has 9.01, roughly 9 you can tell, 9.01. Magnesium 24.31. Generally atomic mass will be roughly double of the atomic number, up to 20. After that it will become more than double. Okay, up to 20, atomic number 20, this atomic mass will be double of atomic number. As for example, I told you that beryllium 4, then mass number is roughly, I am not talking exactly, it is a 9. Okay, then 4 into 2, 8, it is a 9. Okay, and magnesium 12, then its atomic number is 24. And calcium atomic number is 20, then atomic mass is 40. And strontium is 38. And now it is 87.62. And strontium 38 I told you, then it is atomic mass is 87.62. And barium, it is 56 atomic number, then atomic mass is 137.33, more than double. Not only not little more, just what you can tell, not 1 or 2 or 3 more. It is just maybe difference will be more. And barium I told you 56, that is the atomic number, but atomic mass is 137.33. And radium, it is 88 atomic number, and mass number is 226.03. Okay. Now third properties, electronic configuration, already I have told you. Beryllium has this electronic configuration, noble gas helium, you write helium, after that 2s square. Okay, helium configuration, after that 2s square. Magnesium neon Ne, neon gas, neon configuration, and after that 3s square. Calcium, that after the neon, argon, Ar, capital A, small r, argon configuration, after that 4s squared. And strontium, krypton, Kr, krypton gas, Kr electronic configuration, after that 5s square. Like that way, barium, that is a Zenon structure, Xe electronic configuration, and after that 6s square. And radium, radon electronic configuration, and after that 7s square. This I have told about the shortcut electronic configuration. Now ionization enthalpy. That is it is of two types. Ionization enthalpy is in group 2. It is of two types. Ionization energy 1 and ionization energy 2. Okay, there are two types of ionization energy. Why? Because it has 2 electrons in outermost orbit. Then first electron, when it will go then that is called first ionization energy. Energy required to remove first electron from the outermost orbit. 2 electrons are there. Then energy required to remove first electron, that is called first ionization energy, and energy required to remove second electron, that is called second ionization energy. Then by common sense you can think first electron, it is easy to remove first electrons, hence obviously it will require less energy, and after that after removing one electron, one positive charge will come, the charge is developed, then second ionized electron when you will remove, it will require more energy, and then second ionization energy will be greater than first. And also you can understand, because now they are little closer than nucleus, outermost first electron was little far and second was little closer. And now I am telling about for both. And first ionization energy, first I will tell, it is you can say for the beryllium, because it is a small, beryllium atom is a small, hence it's a distance. First ionization energy is more, means 899, 900 approximately, 899, and magnesium 737, okay, and calcium 590, strontium 549, further less, barium 503, further less, radium 509, okay. Then as you are going down, then first ionization becomes less because size is becoming more. Beryllium is a small size, hence it requires more energy because it is close to the nucleus, and it requires more energy in comparison to the other elements of the same group. But if you go down, size will increase, that's why it is easy to remove, that's why value decreases. But here barium and radium both are you can say little close, roughly close. Barium has 503 and radium has 509, okay. Now second ionization energy, all ionization energy is in kilojoule per mole, okay. Then now second ionization energy 1757 for beryllium, 1757, and magnesium less 1450, calcium further less 1145, strontium further less 1064, barium further less 965, and radium 979. Then you have seen trend is same, but value is more. Trend, it is just like a first ionization energy, down it is decreasing, here also it is decreasing, but value is more, okay. Now another property I am telling you, hydration enthalpy, kilojoule per mole, kilojoule per mole. Hydration energy means energy, you can say energy released when 1 mole of water will attach to the atom, okay. Energy gave up, okay, given out, then when water molecule will be absorbed. Then here enthalpy, you can say hydration enthalpy. Hydration means always think H2O, absorption of H2O, hydration energy. Then its value is delta H value I am talking about. It is a negative, in all cases negative means it is going outside. Then in case of beryllium it is more, 2494 means 2494 minus, okay, that is the heat is going out, delta H value. Now in case of magnesium 1921, 1921, it is in minus, and calcium further actually less, means 1577 minus 1577. Again strontium minus 1443, 1443. Barium again 1305, and last radium, it is radioactive, hence there is no question of absorption of water. Now metallic radius of the metal in picometer I already told you 10 to the power minus 12 meter, that is called picometer. Then first you can see that metallic radius of beryllium, it is 111 picometer. And now because size is increasing in group, then obviously radius will increase. Then for magnesium 160, and for calcium 197 increasing, strontium 215 increasing, and radium 222 picometer. Okay, and radium already I told you this is the radioactive, hence measurement is not required. Now ionic radius means after removing outermost electron, when it will be removed both, then what will be the size? The size again it will increase, that is sure short in group down, because size is increasing, then obviously ionic just like metallic radius increased, ionic radius also it will increase. Then value I am telling you now, beryllium is 31 and magnesium is more 72, and calcium is further more 100, and strontium is 118. Furthermore, beryllium is again furthermore 135, okay, and radium is 148, okay, ionic radius. Now come to the melting point, that is in Kelvin. Then now you can see because beryllium is small and electrons is close to the nucleus, hence it is very difficult to remove the electron, and it is very difficult, it will take more temperature for melting. Then now its melting point is highest in the group, that is 1560, means 1560 Kelvin K, okay, and magnesium has less 924, calcium is further more 1124, okay, melting point, because size is becoming big, hence it will require more energy, okay. Beryllium is highest, that region is different because size is small, they are close to nucleus, but here it is increasing, that is due to the increased size, because they will require many orbit will be there, okay. Then here it will require more energy. Then I told you that magnesium 924 and calcium more than magnesium, that is the 1124, and after that strontium 1062, okay, and barium 1002, it is 1062, it is 1002, 1002, and radium 973. Actually this melting value depends on other factor also. Okay, you can't think only in one way. Their situation, what are whether they are in electronic configuration, half filled or fully filled, all things that depends on that also. That's why variation will be there. Okay. Then now boiling point. Boiling point, again obviously boiling point will be more than melting point. Then for beryllium it has 2745 Kelvin, and after that magnesium is less 1363, and again calcium is increasing, that is 1767, and strontium also it is increasing and not a little decrease, just like melting point. Here magnesium is 1767, but here strontium is 1655, little less, and barium is 2078, and this radium has 1973. Okay, it is a study is going on in so many data, so many data for the radioactive is not available. Okay, that's why a study is going on and data is sometimes in some properties data will be not available, but here 1973 is just expected. Density means how much heaviness is there. Density gram per cubic centimeter, means gram per cc. Then it is 1.84, beryllium 1.84. okay, and magnesium little less 1.74. Actually, just rough idea I am telling you, water has density roughly 1 at 25 degree centigrade, 1. Then you know that 1 gram if you take 1 milliliter, 1 ml or 1 cc water you will take, that you know that 1 gram roughly you can understand. Then its mass will, for 1 ml mass will be 1 gram. Here this is the 1.84, means heavier than water. Okay, then beryllium density is 1.84, roughly 2. Okay, magnesium is 1.74, and this calcium is 1.55, strontium is 2.63, means more than 2, double than water, 2.5 times greater, you can understand. Barium again 3.5 times greater, 3.59, and again for radium data is doubtful, that is 5.5 times more than water. Okay, then now come to the these things: electrode potential, reduction potential, standard reduction potential, means whether they will give electron or not. If they will give the electron in solution, when it is dipped in the solution rod, when their rod, metallic rod is dipped in the solution, having the solution having the same cation, then what is the tendency of losing the electron? How much tendency they have? That is called reduction potential. They are losing the electron. Then loss of electron is reduction. Then tendency to lose the electron. Then this is called potential, tendency to lose the electron, that is the potential. Then now you can see who have more tendency to lose the electron. Okay, that is a standard E, electrode potential in volt. Then here means this metal ion will convert to metal. Metal ion will convert to metal. Okay, that is M2+ oblique M means metal ion is converting to metal. Then now I am telling for first, I am telling for beryllium. It has the reduction value means you can say it will start from the minus. Minus means minus shows the reactivity. Sign shows the reactivity. If minus sign is there, it means metal is reactive. If 0 means neutral or no reaction, just like hydrogen gas H plus is converting to H plus, its value is 0. And positive means non-reactivity it will show. As the more value of positive, then metal will be non-reactive. Just like gold, it has a 1.34 plus 1.34. Silver is also, you can say, little less than gold. That's why silver and gold both are non-reactive with air or water, and that's why they are used as a jewelry. You can wear any time, and all jewelry are made from this gold and silver, because they will not react with air and water, and shining will be as it is. Little change will be there in gold or silver, because both are soft metal. Gold is very soft. Then little, to get the little hardness, to give some shape, some other metals are mixed. Okay, just so that it should get some distance. They will get some hardness. Then due to that metal, now it become impure. Generally copper is mixed around 7%, it is allowed. But now this goldsmith people, those who are selling the gold, they will make benefit of this. They will mix up to, you can say, 50% to cheat the people. Okay, that's why nowadays certificate they will give for that. They have mixed the gold in gold that is good. They have not mixed more copper. They will give nowadays certificate, and they will be ready to return the gold. They will take the gold and they will return the same amount nowadays. But in that also, after giving the certificate, they will forget. Shop will be not there after 5 years or 10 years. Then anyhow, to get the hardness, copper is generally mixed, and that's why impurity will be there, and it will tarnish their color. Color will become little dull in both silver and gold after some years. Okay. Then here I am starting with this value I was telling, sign. Negative means more reactive. Less negative means less reactive. 0 means now it will be normal type. And this positive means very less reactive, and more positive means non-reactive, like that. Okay, negative to positive via 0. Okay, you should understand by seeing this value. This is called actually electrochemical series. It is arranged. This reduction potential value is arranged from negative to positive via 0. Then by seeing that, you can understand many properties of the, I can say, metal. All metals are arranged according to the reduction potential value. Okay, reduction potential value, already I told you, this is the standard according to IUPAC. They have given this, they have considered reduction potential as a standard. Then now I am talking about the standard value of beryllium. This is minus 1.97. Minus 1.97. That's why it is reactive. Magnesium is more negative, minus 2.36. means this magnesium is ready to give electron more than beryllium. And now this third one, that is the calcium, that is a minus 2.84, again further more reactive than magnesium because it is more negative, minus 2.84, and again strontium furthermore minus 2.89, okay, more than calcium. Now barium is again further more reactive than strontium because now its value is more negative, minus 2.92, minus 2.92. That's why barium is more reactive than strontium. And now radium and barium both are same value, means their tendency of to losing the electron is increasing as you will go down the group. Okay, and one more property I want to tell you, that is the occurrence in lithosphere, means in earth it is available, on earth it is available, then upper layer is called lithosphere. Okay, then this I am talking about the value in ppm. ppm means parts per million and ppb means parts per billion. ppm, ppb, okay, ppm parts per million and ppb parts per billion. Okay, then here this I am telling value in ppm. Beryllium is in ppm, parts per million, means 2 ppm. They are getting 2 ppm, 2 parts per million. Means in 1 million, you will get 2 parts out of 1000 parts. 2 ppm, very less. And this magnesium you will get that I am telling value in the percentage by weight, then it is a 2.6%, okay, by weight. And this calcium is found more, that is a 4.6% by weight. And strontium is found very high, 384 percentage by weight. Okay, and barium also is found very this 384 I told you, it is not by weight, it is ppm, in ppm. By weight is only I told you magnesium and calcium, 2.76% by weight, and this is and calcium is 4.6% by weight. Okay, and strontium is in ppm, 384 ppm parts per million, and barium is 390 parts per million, and radium is very less, you can tell, 10 to the power minus 6, 10 to the power minus 6 ppm parts per million, very less. Okay, then this I have told you about the these things, physical properties. Okay, little more I want to tell about the two properties. Okay, because question is asked, that's why I am highlighting ionization enthalpy and hydration enthalpy. Okay, then first I want to tell little more about the ionization enthalpy of group 2 elements. The alkaline earth metals have low ionization enthalpy due to fairly large size of atoms. Since the atomic size increases down the group, their ionization enthalpy decreases. Okay, because it is easy to remove the electron from the outside. Size is becoming big and bigger. The first ionization enthalpy. The first ionization enthalpy of the alkaline earth metals are higher than those of the corresponding group 1 metals. If you will compare, in comparison to the group 1, group 2 have higher ionization enthalpies. Okay, this is due to their small size. Group 2 have a small size in comparison to the group 1, then obviously this ionization energy will be more. But in group 2, as it will go down in comparison to their members, it will decrease. Okay, but in comparison to the group 1 will be more than group 2. Now, it is interesting to note that here important things. Second ionization enthalpy of the alkaline earth metals are smaller than those of the corresponding alkali metal. You are comparing with alkali metal, then second ionization energy means second electron you are going to remove. Then here second ionization enthalpies of the alkaline earth metals are smaller than those of the corresponding alkali metals, because very clear, because in the first group they are closer to the nucleus, but in second group they are far from the nucleus, then obviously it will be smaller. Now I am going to tell about the hydration enthalpies. Actually this question is asked in examination, that's why I am focusing on ionization enthalpies. Now I will tell about the hydration enthalpies. Like alkali metal ions, the hydration enthalpies of alkaline earth metals ions decreases with increase in ionic size down the group. Okay, in group 1 also it was decreasing, in group 2 also it decreases. Okay, same pattern, but here I am telling you order. Beryllium ion, all are 2+, need not require to tell the charge, all are 2+. Then beryllium ion is greater than magnesium ion. This is the hydration energy, hydration enthalpy I am telling you. Beryllium ion has more than magnesium, and magnesium is greater than calcium ion, and calcium ion is greater than strontium ion, and strontium ion is greater than beryllium ion. Okay, the hydration enthalpies of alkaline earth metal ions are larger than those of alkali metal ions. Now you can see here it is a group 2, at least in hydration energy it is more. In hydration energy it is more than group 1. Thus compounds of alkaline earth metals are more extensively hydrated than those of alkali metals. Okay, and it will form MgCl2, and calcium chloride exists as a MgCl2 6H2O. Global salt. Question is asked. MgCl2 magnesium chloride hexahydrate 6H2O. Global GLOBAR global salt. Calcium chloride 6H2O. While NaCl and KCl do not form such hydrate. NaCl, KCl, they are not making any hydrate, but magnesium ion and calcium ions they are making hydrate. Okay. Now I am going to tell about the physical properties. Some physical properties. What I told you, that was the data. Many things. Now little more physical properties you should understand. The alkaline earth metals in general are silvery white. and lustrous, shining will be there, and relatively soft but harder. Okay, again I am telling you, alkaline earth metals in general are silvery white, lustrous, and relatively soft but harder than the alkali metals. Okay, beryllium and magnesium appear to be somewhat grayish. This is differences is coming little, you should know. Beryllium and magnesium appear to be somewhat grayish. The melting and boiling points of these metals are higher than the corresponding alkali metals due to a smaller size. The trend is, however, not systematic. Because of the low ionization enthalpies, they are strongly electropositive in nature. Group 2 elements are strongly electropositive in nature. The electropositive character increases down the group from beryllium to barium. Okay, calcium, strontium and barium impart characteristics brick red, crimson and apple green colors respectively to the flame. Just like a group 1 metal they were showing characteristics color, it shows in flame. Bunsen Warner in oxidizing flame, if you take it, this metal, if metal is there, then they will strontium and barium, calcium, strontium and barium. Now these three metal will give, calcium will give a brick red color. Just like a brick you have seen that type of color, brick red, and strontium will give a crimson color, and barium will give apple green. Apple you have seen that type of green, and in crackers whatever green light is coming, that is the due to barium, and brick red color is due to the calcium, and crimson color is due to the strontium. Okay. In flame, actually now reasoning is the same way. In flame, the electrons are excited to higher energy levels, and when they drop back to the ground state, energy is emitted in the form of visual light. I already have discussed in details with group 1. Okay, here also same things are there. The electrons in beryllium and magnesium are too strongly bound to get excited by flame. This beryllium and magnesium, they will be not excited. The beryllium and magnesium are the strongly bound to get excited by flame. Hence, these elements do not impart any color to the flame. Question is asked. The flame test for calcium, strontium and barium is helpful in their detection in qualitative analysis and estimation of flame photometry. Already lab you are doing and this lab analysis. Practically will do that time. This flame test is very important. By seeing the color directly you can tell, okay, in this salt, given salt, calcium is present or strontium is present or barium is present. Quickly you can tell by seeing the color. The alkaline earth metals, like those of alkali metals, have electrical and thermal conductivities. These are also electrical conductivities and thermal conductivities. Electrical conductivity means current will flow through these metals, and also heat will also flow. Heat means thermal, okay, which are typical characteristics of metal. Metal has some fixed characteristics. Then this is the common flow of current, flow of heat. What I discussed, that are the special characteristics of metal. Then now I have discussed general things. I have discussed about the group 2 metals, physical properties especially I have focused. Now I am stopping only here. Next class I will discuss chemical properties of group 2 metals. Thank you.